When you go for a run, something remarkable happens inside your body. Your muscles burn energy. Your heart pumps faster. And your liver sends a message to your brain. That organ-to-organ communication could be the key to understanding why physical activity protects us from Alzheimer's disease. And scientists at UC San Francisco just figured out how it works. I'm your host, and this is Better Health Faster, where we translate the latest research into practical steps you can take today. Here's the puzzle that kept researchers guessing for 6 years. Exercise clearly benefits brain health. Study after study confirms it. But the mechanism? That was the mystery. They knew that when you exercise, your liver releases an enzyme called GPLD1, and they knew GPLD1 seemed to rejuvenate aging brains. But there was a problem. GPLD1 cannot cross the blood-brain barrier. It physically cannot enter the brain. So how on earth was it protecting your neurons? To understand the answer, we need to talk about what happens to your brain as you age. And it's not just about neurons dying, it's about barriers breaking down. Your brain has a security system. It's called the blood-brain barrier, and it's essentially a selective filter that keeps harmful substances in your bloodstream from entering your brain tissue. When you're young, this barrier is remarkably tight. The cells lining your brain's blood vessels lock together, forming an almost impenetrable wall against toxins and inflammatory molecules. But as we age, something troubling happens. A protein called TNAP starts building up in the cells that form this barrier, and TNAP weakens the wall. According to research from the UCSF Bakar Aging Research Institute, as mice age, TNAP accumulates in the cells lining their blood-brain barrier, making it progressively more permeable. When this barrier becomes leaky, inflammatory molecules that should stay in your bloodstream can slip through into your brain tissue. This contributes to cognitive decline. This is where the mystery began. 6 years ago, a team led by Dr. Saul Valletta at UCSF discovered something intriguing about exercise and the liver. The team found that physical activity triggers your liver to release ZPLD1 into your bloodstream, and when they gave ZPLD1 to sedentary mice, their brains looked younger. But here's what kept them puzzled. GPLD1 is too large a molecule to pass through the blood-brain barrier. It simply cannot enter the brain directly. So if this liver enzyme couldn't reach the brain, how is it producing such clear cognitive benefits? The team spent 6 years searching for the answer. In February 2026, they published their answer in the journal Cell. And it's elegant. GPLD1 doesn't need to enter the brain at all. It works from the outside. The researchers discovered that GPLD1 acts like molecular scissors. It circulates in your blood, finds TNAP anchored to the outside of brain blood vessels, and snips it off. Think of it this way. GPLD1 doesn't need to enter the building to fix the roof. It reaches up from the bloodstream and repairs the barrier from the outside. By removing TNAP from the blood-brain barrier, GPLD1 allows those barrier cells to tighten up again. The wall becomes strong again. Leakiness decreases. As Dr. Valletta explained in the UCSF press release, this discovery shows just how relevant the body is for understanding how the brain declines with age. The implications for Alzheimer's disease are significant. When the team tested their findings in mouse models of Alzheimer's, the results were remarkable. Increasing liver-derived ZPLD1, or inhibiting TNAP activity, reversed Alzheimer's-related changes in gene expression in the mouse brains. Even more promising, treatment reduced amyloid beta pathology, those protein plaques that are hallmarks of Alzheimer's disease, and improved cognitive deficits in the mice. Now here's where we need to be careful. This research was conducted in mice, not humans. The path from mouse studies to human treatments is long and uncertain. That said, this research opens exciting possibilities. Drug developers are now investigating whether TNAP-inhibiting medications could one day help protect human brains the same way. But while we wait for pharmaceutical solutions, the research points to something you can do right now, something your liver already knows how to do. Exercise. Regular physical activity naturally triggers your liver to produce GPLD1, You don't need a prescription. You don't need to wait for clinical trials. Your body already has this system. The research suggests that aerobic exercise appears particularly effective at stimulating liver enzymes like ZPLD1, activities that get your heart rate up and keep it elevated. That means activities like brisk walking, jogging, cycling, swimming, or dancing. The key word is brisk. You should be slightly breathless, but still able to hold a conversation. And here's encouraging news. You don't need to train for a marathon. Moderate, consistent activity appears to be what matters most for these protective effects. The research team emphasized that exercise benefits accumulate over time. This isn't about one intense workout. It's about building a sustainable habit over months and years. It's also worth noting that it may never be too late to start. The research suggests these protective liver-to-brain mechanisms remain active throughout life, even in older adults. Now, some researchers have raised concerns about this line of research, and I think it's worth addressing them honestly. First, Alzheimer's disease is complex. Targeting a single pathway, even an important one, may not be sufficient for treatment. The disease likely involves multiple mechanisms. Second, there's an ethical question about developing drugs that mimic exercise benefits. Could such medications lead people to skip physical activity altogether? Physical activity does far more than just trigger CPLD1 release. Exercise benefits your cardiovascular system, your metabolism, your mental health, your immune function. The list goes on. A pill that mimics one exercise pathway wouldn't replace all those other benefits. So regardless of what pharmaceutical developments emerge, movement matters for reasons beyond brain protection. If you're considering starting an exercise routine specifically for brain health, here are some practical guidelines based on what the research suggests may help. Aim for at least 150 minutes of moderate aerobic activity per week. That's about 30 minutes 5 days a week. But remember, something is always better than nothing. If you have existing health conditions, always consult your doctor before starting a new exercise program. They can help you find activities that are safe and appropriate for your situation. Consider making exercise social. Walking groups, swimming classes, or dance sessions with friends can help you stay consistent, and social connection has its own brain benefits. And if you're finding this kind of research useful for making your own health decisions, consider subscribing. We explore stories like this every week, turning new science into practical takeaways. Looking ahead, the UCSF team is continuing their research. They're investigating whether drugs that inhibit TNAP could someday offer similar protection to people who can't exercise. That could be particularly valuable for people with mobility limitations, chronic illnesses, or disabilities that make regular physical activity challenging. Until then, for those who can move, this research adds one more reason to make physical activity a priority. Your liver is listening, and it's ready to send the signal. Let's recap what we've learned today. Your liver produces an enzyme called ZPLD1 when you exercise. This enzyme can't enter your brain directly, but it doesn't need to. GPLD1 works from outside the brain, removing a harmful protein called TNAP that makes your blood-brain barrier leaky with age. It repairs the barrier from the bloodstream. This discovery by UCSF researchers, published in Cell in February 2026, helps explain one way exercise protects against cognitive decline and potentially Alzheimer's disease. While drug development continues, the most effective way to activate this protective pathway today remains simple: regular physical activity. Your body already knows how to do this. Remember, this content is for informational purposes only. Always consult your doctor before making changes to your exercise routine, especially if you have existing health conditions. Thank you for spending time with Better Health Faster. Until next time, keep moving. Your liver and your brain will thank you. The research published in Cell demonstrated that exercise-induced liver signaling represents a new understanding of organ-to-organ communication in brain health. GPLD1 is classified as an exerkin, an exercise-induced molecule that signals between organs. This category of molecules is an emerging area of aging research. Understanding how the liver communicates with the brain through the bloodstream opens new research directions beyond just Alzheimer's, potentially for other age-related cognitive conditions as well. The 6-year investigation by the UCSF team represents the kind of persistent, methodical research that advances our understanding of complex biological systems. Dr. Valleda's team at the Bakar Aging Research Institute continues to explore how the body and brain communicate, potentially uncovering more protective mechanisms. While waiting for future treatments, consider exercise as an investment in your cognitive future, a daily deposit into your brain health savings account. Start where you are. If you're currently sedentary, even a daily 10-minute walk activates these pathways. Progress comes from consistency, not perfection. And remember, the research suggests these benefits accumulate over time. Every walk, every swim, every dance session contributes to your liver's ability to protect your brain.